Hi everyone, I hope that you're having a fantastic day. It's your friendly neighborhood math teacher here, and I wanted to give you a quick lesson on what we are doing today. So everybody needs to make sure that they have this worksheet in front of them, and it should say trend lines that intersect on top here. So trend lines that intersect right there, okay? So we are going to be talking about our pattern rules, and we're going to be graphing them, but now instead of seeing lines that never cross, so those parallel lines like we saw on Monday, now we are going to see lines that are going to cross. Okay, so that's our spoiler for today. So let's look at this. It says, consider trends on the graph and graph them below. So consider the trend lines and graph them below. The first one says number of tiles, and our rule is position number or step number times 5 plus 3. And the second one says that our rule is our number of tiles is equal to our position number or step number times 6 plus 2. Okay? And so we're going to graph these and see kind of what happens. So you guys need a pen and a pencil. I want you to take a couple of seconds right now to try to graph these. So some ways that we could do this. You could make a table of values, or you could just try to graph them as you go. So take a couple of seconds right now. We're going to pause the video. So Andrew, please pause the video, and you're going to graph them. Okay? Okay, so a couple of things about our graph that we all need to make sure that we're busting some bad habits before they happen. The first one is that I want us to start thinking about our pattern rules, so these pattern rules right here, as equations. This is going to help us long term, okay? So if this was an equation, I could write this using our equations as the first one is going to be y equals 5, because that's our position, what we're multiplying, x plus 3, okay? This is our first equation. So our multiplier plus our constant. That's what our equations are always going to look like. Multiplier plus a constant. The second equation could look like y equals, our multiplier here is 6. So does everybody see how that's our multiplier right there? That's what we're timesing by. So our multiplier, which is 6, x plus our constant, which is 2. And our constant here is 2. Do you guys see that? Okay, so now that we can see that we have some equations, let's try to graph them. Graphing rule of thumb. We always need to make sure that when we are graphing, we have a consistent axes. And what that means is that we need to make sure that it's labeled. So I have my x, my y, okay? I also need to make sure that when I am graphing, every square always stays the same amount. So I'm never going to go, okay, this square is going to be 1 unit, and then the next one's going to be 5 units, and then the next one's going to be 10 units. Every square needs to be the same amount, okay? In this case, I just made every square 1. So I'm going to go up by 1s on my y-axis, okay? So 1, 2, 3, 4, 5. I'm going to put my 5 there. 10, 15, 20. Okay. Same thing on my x-axis. Now, the other rule of thumb when I'm graphing is that I want things to be as spread out as possible. I don't want all of my data to just be in this portion of the graph, okay? My graph is like a beautiful piece of artwork. I want it to fill the whole thing. So what I did, because I want to go up to, I'm going to try to go to 5 steps. We're going to see that it's not going to fit, but rule of thumb is 5 steps. I'm going to spread out my 5s, but I'm not going to just go up by 3s for my first one, then 10 for my second one, then 3s again. Okay, that's not a thing. My boxes need to be the same amount. So I go up, I'm going to do 1s, but it's going to take 4 blocks to get to 1. So 1, 2, 3, 4. 1, 2, 3, 4 is 2. Okay, that's a 5. Yes, I know many people that does not look like a 5. All right, there we go. okay? So we can see that I'm going up by consistent amounts. In my y-axis, every block is 1, it's always 1, and in my x-axis, where every block is 0.25, or it takes 4 blocks to get to 1, right? Now I'm going to graph things. So I'm going to graph my patterns. There's 2 ways that we could do this. 3 ways that we could do this, actually. The first one is that you could make a table of values. Nothing wrong with making a table of values, okay? That is a good way to graph things. The second one is that you could do a table of values in your head without actually writing it down. So I would say, if I'm looking at this yellow curve, my yellow line right here, so this one right here, 5x plus 3, or position number times 5 plus 3. When my position number is 1, 1 times 5 is 5, plus 3 is 8. So I'm going to have a dot at 1, and 8 right here. That's not on the line. Yours is going to look better because it's not on an iPad. Right here, okay? I'm just going to make it nice and big so it kind of fills the line. There we go. Yes, Alex, I know it looks ridiculous. Okay, so that's one way to do it. And we can actually rewind that a little bit too, so that when I have no numbers and when I'm at step 0, 5 times 0 is 0. My constant is 3, so I'm always going to have 3. Okay, always going to have 3. So, and you can keep going until you get your straight line. The other way that we can do this is once I have a couple of dots, I can use my multiplier to find my next step. Okay, so my multiplier in my first one is 5. Does everybody see how that's 5? I can count from my dot, so if I take my dot at 1, up 5, and then just go over to the next step. So if my dot's at 8, I'm going to count up 5. So 9, 10, 11, 12, 13. That's my next dot, okay? So I'm just going to put a little dot there to hold my place, and I'm going to go over to my next step. So at step 2, there should be 13 dots. Okay? I want you guys to use whatever method you like, so whether it's table of values on paper or in your head, or graphing using what I just did, I want you to graph both lines. So you're going to pause the video again and graph both lines. And then just make sure that your dots are consistent, and we're going to use a dashed line. So when you guys press play again, you should see that everything is kind of graphed. Okay, the last thing that I'm going to hint at when you are using your graph is that you make sure that you are using a ruler to help you with your dotted line. So I don't know if you guys can see the ruler that I'm using on my screen right now, but I'm going to try to line it up as best as I can, and then I'm going to make my dotted lines with my ruler. Okay, there's one, and these should all be linear lines, so that your ruler should work wonderfully with them. All right, there we go. Okay, ruler can go away. So your graph should look kind of like this, and if your graphs are not looking like this and you're having a hard time still with the graphing thing, please come in and see me tomorrow at lunch, okay? I'm in here. I will bring some cheap Valentine's Day candy, and maybe we can just, you know, have a little, like, jam out with some math, okay, that's going on. All right, so here's my 2 lines, and we should notice with these 2 lines that they are crossing, specifically that we see them cross right here. They both had a point at 1 and 8. Okay, and I'm going to write that down here. So we see them crossing here at x is 1 and y is 8. Okay, that's our point of intersection, or we call that our POI, point of intersection. All right, cool. Okay, so let's talk a little bit about these crazy equations that I put up here and didn't really talk any more about. You guys are probably like, Ms. Cox, you are crazy. We have no idea what you're doing. This is the most impossible math, and we're just done, and we think that you should have made a really awesome video instead of a math video, and maybe we should have watched like something cool. Okay, well, newsflash, I am awesome. You're gonna get your daily dose of awesome, even though I am not here, okay? All right, so this is the stuff that we're seeing right now. Move down to the rest of your page just for a second. Okay, so we're looking at this part right now, and I want everybody to highlight this equation right here. So this is going to be what we're going to call our equation of a line. And this shouldn't be any shock because we've only really been dealing with things that are straight line. We'll use some nice pink for Valentine's Day. Okay, so this is our equation of a line, and there's a couple of things that we know about our equation of a line. First off, every single pattern rule that we have ever talked about in our class, even though we've had 4 snow days, has made a line. And every single one of them can be written like this. So we have a y, we have a multiplier, and then we have a constant. So again, a y, a multiplier, and a constant. And we do this because we are lazy people, and it takes so much time. So it takes so much time to write out our pattern rules, and we want to have kind of a different way of doing it. Okay, so if I'm looking here, oops, sorry. My y, this is my dependent variable. And my dependent variable is also known, what we've been calling our total number of tiles. Okay, so our dependent variable is also what we've been calling our total number of tiles. Okay, our m right here, this is our multiplier or our slope. And like I said to you on Monday, we can also show this as m is the same as saying our rise over our run. Okay, so if we weren't given a pattern and we were just looking at the line, then we could use this idea, all right? Our x, so our x here, that's going to be our independent variable. Which we also call our position number. And finally, our b term, that is our constant or initial value, which we are also going to start calling our y-intercept because it touches or intersects or intercepts the y-axis. So just to recap, we have our y, which is our total number of tiles, equals our multiplier times our position number plus our constant or our initial value. Okay? All right, so this should all be filled in. If you need to pause and go back, you can. Once that is done, we are going to flip the page, please. Okay, on the back, we're asked to determine the rule for the graph. And this is where I was saying we need to use that rise over run, because notice that we've only been given a line, no patterns, okay? The nice thing about this graph, though, is that you have distinct dots. So there's one here, there's a point here, 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 and they're happening on the lines, which is really nice. Also, this is basically one of the lines that we've just graphed. So let's look at this. Okay, I have a dot here, and what I want to do is we're going to draw a triangle. So you're going to pick any 2 dots on the graph and draw a triangle connecting them. Okay, so I've decided that I'm going to pick this dot. Let's pick a nice little red here. It looks kind of pink. So here I have here, and just to demonstrate, I'm going to draw a big triangle. You can draw it as big or as little as you want, but it's connecting the 2 dots. So one line's going to go down, one line's going to go across. Do you guys see how I've made a triangle? Okay, here's my triangle. Now we're going to count up. Okay, so I want to see how big my triangle is and how wide my triangle is. So here, if I'm starting at 8, I'm going to go up to 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 10 squares. So my rise is 10. And I notice that I'm starting at step 1 or position 1, and I'm ending at 3. So that is 2. Okay, that's 2 positions or 2 blocks. Okay, so I have my rise, and remember that I called this is my rise. This is my run. And we just said that we can find our multiplier by doing rise over run. So here I would take my 10 and divide it by 2, which gives me 5. So I know my multiplier, my m, is 5. Okay? My y-intercept is where this line kisses or touches that y-axis. If I'm looking here, my y-intercept, or my b, is going to be 3. Okay? And if you're confused with where I'm getting m and b from, flip your page again, and I'm just getting them from those labels. Okay? So now I'm going to make a y equals equation. So my y equals my m, which we said was 5. My x always goes beside my multiplier, plus 3. Okay? For number 3, you're just going to look here. It's saying how many tiles will be in position 3. I find position 3 on my graph. I go up until I touch the line, and then I see that there's 18 tiles at position 3. Okay, 18 tiles at position 3. You can read this from the graph, or the other way that you could have done this was use our pattern rule. 5 times 3 is 15, plus 3 is 18. Good. Sorry, technical problems. There we go. Okay, so it says, imagine you have a pattern rule with a multiplier of 4. You want the trend line for this pattern rule to intersect the pattern rule above at position 3. What would the rule be in order for them to intersect? Okay, I think that for 3, 4, and 5, from 4 to 8, we are going to do this together on Friday. So please put this in your notebook. We're going to do this together. And you guys can start working on the worksheet. If you finish the homework sheet, come back to these questions and try to do them, or study for tomorrow's test. Quiz. It's a quiz. Sorry, didn't mean to scare you. Quiz, 100% quiz. And then after the quiz, we will go through this again very quickly, and then just do 4 to 8 together. Okay? Sound good? Have a great day, guys.